You stand on the shore at dawn, and the water does not move. The tide has flatlined into a terrible eternal stillness, and overhead the moon hangs smaller than you remember, a pale betrayer already retreating into the void, and you feel it in your bones, the wrongness, the sudden absence of a gravitational heartbeat that has pulsed for 4 billion years, the ancient contract between world and satellite dissolving into mathematics and distance. And you know with a clarity that empties your soul that the cosmic anchor has finally snapped and the Earth is beginning its long, chaotic wobble into oblivion alone, unmoored, spinning toward a death that will take eons, but has already begun. The moon is leaving, not in some distant hypothetical future, but now, and has been since the moment of its violent conception when the protoplanet Theia slammed into the molten infant Earth and vaporized itself into a ring of superheated debris that coalesced into our companion, our stabilizer, our executioner. The physics are elegant and merciless. Tidal friction, the drag of ocean water moving across the seafloor as the moon's gravity raises two bulges and the hydrosphere acts as a brake-on. Earth's rotation. Every second of everyday kinetic energy is stolen from our spinning world, and through the conservation of angular momentum, that energy is transferred to the moon, increasing its orbital velocity. Faster orbit means higher altitude. 3.8 centimeters per year. Measured, confirmed, inevitable. In the Devonian period, 400 million years ago, when the first fish crawled on a land, the moon loomed 40% larger in the sky, and a day lasted barely 22 hours. The moon has been fleeing ever since, climbing steadily away from us on an invisible ladder built from stolen rotation. In another 2 billion years, if the sun does not consume us, first the moon will have retreated so far that it will appear as a dim wandering star, and its gravitational influence on Earth will be a whisper, a footnote in the equations of our doom. But the catastrophic threshold is crossed long before then, because Earth is not a simple spinning sphere, it is a finely tuned machine, and the moon is the flywheel that keeps it stable. Remove the flywheel, and the machine tears itself apart. The first victims are the oceans. Not the dramatic death of evaporation, but something slower, more insidious, a suffocation that begins at the margins and spreads. The intertidal zones, those liminal spaces where sea meets land, where evolution first experimented with amphibious life, are the canaries in this coal mine. As the moon retreats and its gravitational pull weakens, the tidal range diminishes. The twice-daily pulse that has flushed estuaries and oxygenated coastal shallows for eons begins to fade. Species that evolved with the rhythm embedded in their DNA fail to reproduce. Grunion that beach themselves to lay eggs during spring tides find no spring tides. Fiddler crabs that time their mating to the lunar cycle lose synchronization, and the population crashes. But this is merely the surface horror. Beneath the waves, the true catastrophe unfolds. The global thermohaline circulation, the great oceanic conveyor belt driven by temperature and salinity gradients, and crucially by tidal mixing, begins to stall. In the North Atlantic, cold, dense water that should sink and flow southward along the ocean floor, carrying oxygen to the deep trenches, slows to a crawl, then stops. The abyssal plains, the deepest, coldest regions of the ocean, become anoxic. Without oxygen, the aerobic bacteria that decompose organic matter die and are replaced by anaerobic microbes that produce hydrogen sulfide as a metabolic byproduct. The deep ocean begins to reek a stench of rotten eggs that eventually surfaces as the sulfide-rich water upwells during the chaotic climate shifts to come. Phytoplankton, the microscopic foundation of the marine food web, and the source of more than half of Earth's atmospheric oxygen, require nutrient upwelling from the deep to sustain their blooms. As the conveyor belt dies, the surface waters become nutrient-depleted deserts. The phytoplankton populations collapse. Zooplankton that feed on them starve. Fish that feed on zooplankton vanish. The ocean food web unravels from the bottom up. And the oxygen those phytoplankton produce, the breath of the world, diminishes. The atmosphere begins to thin, not all at once, but in a slow, inexorable decline that will take millennia, but leaves every generation gasping a little harder than the last. The coasts, once vibrant with life, become tideless morgues where the water laps weakly against shores covered in the gray sludge of decomposition, and the air tastes of sulfur and death. But the oceans are only the beginning. The true existential terror lies in the Earth's axial tilt. Our planet spins at an obliquity of 23.5 degrees, a tilt that gives us our seasons, the predictable march of winter, spring, summer, fall that has governed the evolution of every terrestrial ecosystem. This tilt is not stable on its own. Without the moon's gravitational torque acting as a cosmic gyroscope, Earth's axis would wander chaotically, pulled by the gravitational influences of Jupiter and the Sun. Computer simulations show that a moonless Earth could see its obliquity swing from 0 degrees, meaning no seasons at all, just an eternal frozen poles and scorching equator to 85 degrees, where the poles would point almost directly at the sun during summer, creating temperature extremes incompatible with complex life. As the moon retreats and its stabilizing influence wanes, the wobble begins. Slowly at first, over centuries, then accelerating. 1 decade, the northern hemisphere tilts further toward the sun than it has in 10 million years. Summer becomes a 6-month inferno. The permafrost melts, releasing gigatons of methane. The Amazon rainforest ignites. Temperatures in the Sahara exceed 70 degrees Celsius, and the sand fuses into glass. Then the wobble reverses. The same hemisphere tilts away, and winter becomes a sunless freeze that lasts half a year. Glaciers that took a century to melt refreeze in months. The North Atlantic becomes a sheet of ice. Hurricanes that form in the tropics now wander into temperate zones because the jet streams are in chaos, responding to temperature gradients that no longer make sense. In the southern hemisphere, the same madness unfolds on an inverted schedule. Antarctica, the frozen continent, experiences a summer where the sun never sets and temperatures soar above freezing. The ice sheets collapse. Sea levels rise then fall as the water refreezes elsewhere in unpredictable patterns. No species can adapt. Migration routes that worked for millennia lead to dead ends. Birds arrive at breeding grounds to find them underwater or encased in ice. Trees accustomed to a predictable growing season leaf out during a killing frost or remain dormant during a brief fall spring. The chaos accelerates. The wobble becomes a drunken stagger. There are no seasons anymore, only random swings between uninhabitable extremes. Agriculture collapses. Famine spreads. And the sky itself begins to look wrong. The constellations shifting positions as the axis reels. Beneath the surface, beneath the dying oceans and the reeling tilt, another catastrophe is brewing in the planet's core. The Earth's magnetic field, that invisible shield that protects us from the solar wind, is generated by the geodynamo, a complex process in which the liquid iron outer core flows around the solid inner core, driven by heat convection and the Coriolis effect from Earth's rotation. This dynamo requires two things: a sufficiently rapid rotation and vigorous thermal convection. The Moon's tidal forces have been essential to both. The tidal flexing of Earth's mantle generates heat through friction and helps maintain the convection currents. As the moon retreats, that flexing diminishes. Simultaneously, Earth's rotation slows, stolen by the moon's recession, and the chaotic wobble disrupts the Coriolis flows that organize the dynamo. The magnetic field begins to weaken, not uniformly, but in patches. The South Atlantic anomaly, a region where the field is already weaker, expands. Compasses spin uselessly. Satellites in low orbit are fried by increased radiation exposure. Then the field begins to flicker, collapsing and reforming in irregular patterns. During these transitions, the surface is exposed to the full fury of the solar wind, a stream of charged particles traveling at hundreds of kilometers per second. These particles slam into the upper atmosphere, stripping away molecules. Oxygen and nitrogen are ionized and accelerated to escape velocity. The atmosphere thins. The sky, which was blue because of Rayleigh scattering in a thick atmosphere, begins to fade to a darker violet, then a bruised indigo. The ozone layer, already weakened by the chaotic climate and increased volcanic outgassing from the destabilized mantle, disintegrates. Ultraviolet radiation floods the surface, sterilizing the land. The auroras, once confined to the polar regions, now dance across the equator, a beautiful symptom of a dying world. And still the atmosphere bleeds into space molecule by molecule, the solar wind, scouring it away like sandpaper on skin. Earth is becoming Mars, a cold, dry rock with a thin wisp of an atmosphere incapable of supporting life, incapable of holding heat. In the deep future, long after humanity has either fled or perished, the Earth that remains is a husk. The wobble has reached its maximum chaos, the axial tilt swinging wildly between extremes on timescales of thousands of years. The oceans, if any liquid water remains, are isolated hypersaline seas surrounded by deserts of salt and rust. The atmosphere is a thin ghost, barely enough to carry sound. The temperature swings are absolute, from blistering heat on the sunward side to cryogenic cold in the shadow. The surface is scoured by unfiltered solar radiation and cosmic rays. Nothing grows. Nothing moves. The continents themselves are barely recognizable, reshaped by the chaotic volcanism and the erratic tectonic activity that followed the mantle's destabilization. And in the sky, now black, even at noon, hangs the moon, a tiny pale disk no brighter than Venus, once appeared from Earth, receding still on its endless trajectory outward. It is small and indifferent, a rock obeying the cold equations of orbital mechanics. It does not remember the tides it once commanded, the life it once nurtured. The moon was never alive, but Earth was, and the moon made that possible. It stabilized the axis, giving life the gift of predictable seasons. It raised the tides, stirring the primordial oceans and concentrating the organic chemistry that sparked the first cells. It slowed Earth's rotation from a 6-hour day to a 24-hour rhythm, allowing photosynthesis to flourish. Without the moon, we would never have evolved. And now, without the moon, we cannot survive. The great lunar escape is complete. The 4-billion-year marriage is over. The divorce is final. And Earth spins alone, a wobbling grave in the dark, a monument to the fragility of the conditions that allow a rock in space to bloom with life, and a warning that nothing, not even the ground beneath our feet, is truly permanent.